So today we are going to start our topic, equation of a line in space. Now we already learned how to find equation of a line in two dimension, right? So we have learned in class 11 about that. So in there we needed a point and a slope to find the equation of a line, right? So in here we'll learn how to find the equation of a line in space, or it's known as three-dimensional. Okay, the first we'll do is we'll find the equation of a line when certain things are given, which is, so what I will do is equation of a line passing through a given point, and parallel to a given vector B. So we will learn how to find the equation of such line whose through a given point is given and a vector parallel to the line is given. So let us see, it's just like the 2D one. In 2D, what we did, we had, suppose we have x-axis and y-axis like this, right? I'm just realizing that thing in 2D, what we are going to do in 3D. So suppose we had a line like this. How to find the equation of the line? The first thing we did, we already know that the slope of this line is given, that is m. Okay, now we have to find the equation of a line. So in order to find equation of a line, the first thing we do is take a general point x, y, right? And there is a point that is given. So let us write that one as x1, y1, right? So these two are given. What is that? A point is given through which the line passes and the slope of the line is given, that is m, right? So we have to find the equation of the line in 2D. So what was that? It was y minus y1 is equal to m into x minus x1, right? This was it. Clear? Now in case of 3D, you see the given point x1, y1, the point is there, it is same. Now a parallel to a given vector. Now parallel to a given vector, it means what? They are talking about direction. If a vector is parallel to another vector, it means what? The direction is same, right? And this slope also kind of like gives you the direction. So when you're talking about slope in 2D, so we are talking about parallel vector in 3D. Understood? In order to find the equation of a line in 3D. Okay, so let's move on. So first thing, a point is given. So let us say the position vector, let us draw the diagram first. So suppose we have 3D. So this one is our x, this one is our y, this one is our z. Okay, now we have a line. Let's draw the line. So this is our line for which we have to find the equation. Okay, now what is given? A point is given. So let us say that this is our point. Now obviously we know one thing, when you're talking about point in 3D or in vector, we always take it into consideration of the position vector of that point. The point is not that important, the position vector of that point is important. And what is position vector of the point? It's the position of the point with respect to the origin. Okay, so I have taken a point. Now I need a parallel vector to this one. So let us say that there is a vector like this to which this line is parallel to. Okay, now after knowing the slope and a point, I have taken what? A general point. So the same thing what I will do, I will take a general point P in here. And I told you what, in 3D the point is not that important, the position vector of that point is important. So I draw a picture like this. Okay, so what do we have? We have OA vector, and OA vector is actually what? Position vector of the given point A and let us say the line which we have to find the equation of, let us say that to be L. So OA is position vector of the given point A on the line L. Okay, now you write here, so OP vector is equal to position vector of a general point. Clear? So one thing, let us give OA vector a name. Let us say that OA vector is A vector. Okay, now general point, when we are talking about general point in 3D, we take it as R vector. Okay, so this one will be our R vector and this one will be our A vector. Clear? Understood? Can anybody tell me what will be our AP vector equal to? AP vector, you see AP vector is what? Parallel to this one. So we have already discussed, when two vectors are parallel or when two vectors are collinear, can I say A vector is equal to lambda B vector? When two vectors are parallel, look, when I'm talking about A and B are parallel, here A and B are different thing. I'm talking about this one. When A vector and B vector are parallel, then we can write it like this. A vector is equal to lambda B vector. Understood? They are collinear. We have discussed this one before. So AP vector, can I write this one as lambda B vector? Understood? Because this AP vector is parallel to B vector. Since AP vector is parallel to B vector. Am I clear? After this, what I see is, now forget about this B vector. Can you see a triangle in here? I see a triangle, right? So what I will do is, by applying triangle law of vector addition. So tell me, what do I see? If I apply triangle law of vector addition, now look at it very carefully. What I see in here, the vector is starting from here, OA plus AP, and this is opposite direction. So what I can write, OA vector plus AP vector is equal to OP vector, because it's in the opposite direction. Understood? So this is what we get by applying vector addition, triangle law of vector addition. So now write all those. OA vector is A vector plus AP vector is what? Lambda B vector, and OP vector is equal to R vector. Yes or no? Everybody clear or not? Clear? So our equation, therefore the required vector equation of the line is given by is R vector is equal to A vector plus lambda B vector. It's so easy. So what is A vector? If somebody asks you what is A vector is the position vector of the point through which the line passes. And what is B vector? B vector is the vector which is parallel to the line. Understood? So this is how we find the vector equation of a line. Okay. Now we will try to derive the Cartesian equation of a line. Achha, what is Cartesian? We have heard of Cartesian coordinates, right? Cartesian coordinates means what? X, Y. Now here we are dealing with 3D, so it will be X. So we have already done the vector equation. Now we will be doing the Cartesian equation of the line. So now Cartesian equation of the line. Now how is that given by? So first thing, I told you what R vector is the general point, right? So R vector is general point, means what? X, Y. So in 3D it will be what? In 3D it is what? X, Y, Z, right? So if I have to write position vector of X, Y, Z, it will be Xi cap plus Yj cap plus Zk cap, right? And then I told you the given point is what? x1, y1. So in here the given point will be what? So A vector will be what? x1 I cap plus y1 j cap plus z1 k cap. We talked about this because x1, y1 is the given point. Clear? Now our B vector. So what should I give? So let us write this one as A I cap plus B j cap plus C k cap. Okay. Now what was the equation we derived for vector equation? It was R vector is equal to A vector plus lambda B vector. This was the equation. Now put all those in here. So what do we have in component form? All those component forms in here. So this one becomes Z k cap is equal to, this one becomes x1 I cap plus y1 j cap plus z1 k cap plus lambda into A I cap plus B j cap plus C k cap. This is what I get, right? Now let's do one thing. Let's take this one this side. So what I get if I take this one this side? So I get x minus x1 I cap plus y minus y1 j cap plus z minus z1 k cap is equal to lambda ai cap plus b j cap plus c k cap. Right? Now we already know when two vectors are equal, the corresponding components are equal, right? So what is the component of I cap? It's x minus x1. So it is x minus x1 is equal to lambda a. Lambda is multiplied with each of them. Now another one, y minus y1 is equal to lambda b. Now z minus z1 is equal to lambda c. Right? Now from here let's find the lambda. So lambda is equal to x minus x1 by a. Lambda is equal to y minus y1 by b. Then what do you have? Lambda is equal to z minus z1 by c. Now all these lambdas are equal, right? So what we can say? X minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c. So this is our Cartesian equation of the line. Am I clear? If somebody asks you what is the Cartesian equation of the line, this is it. So what is this ABC? ABC are the components of the parallel vector and x1, y1, z1 is the components of the position vector of the point. Understood? Clear?